In progress.
Hello, JB.
Hello?
You. Hello.
Hello? Yeah.
Hello. Good day. Yeah. How are you doing?
Yeah, I'm doing good. How are you?
How are you doing? I'm greeting. Yeah, I'm good. I'm good. And you? I'm good. And you?
Yeah, I'm good as well.
All right. All right. Yeah, so we can start. We are ready.
Okay. So today we will be learning about energy and energy transfer. So first we will look at some vocabulary words. So first, getting to know energy. So energy is the ability to do work. So everything requires energy. So even you running, walking, using your computer, um, kicking a football, and everything needs energy in order to move and do any sort of work. So energy is required to do everything. But one thing about energy is that they can transfer into other objects. That is called energy transfer. So energy is being moved from place to place, from object to object. We will look at that more closely in the video as well. But batteries are stored energy that can change one form into another. So you guys know batteries, right? It's shaped like this, but these are basically stored energy, which you can use to plug it into other electrical devices. So these are sources of stored energy. And solar cells are, you can see in the picture on the right, these are solar cells. They convert the sunlight into electrical energy. So we will look at that in the video as well. And then we also have wind turbines. It's shaped like this. These are very large devices that produce energy by the spinning blades. As the wind blows on it, the blades spin faster and faster, and that generates electricity. That was a short vocab before we begin. And now let's look at the video and learn more about energy and energy transfer. So,
Jeffrey, do you still need me to keep paddling? Jeffrey!
yeah, that was the video about energy and energy transfer. That was actually just the first video, and I did prepare a second video which focuses a specific type of energy. So we will focus on more of the mechanical energy, which is the energy that makes things move. And potential and kinetic energy are the two main types of mechanical energy. So we will focus more about movement. But what exactly is kinetic energy? So kinetic energy is the energy in motion. So anything that is in motion has or is displaying kinetic energy. Potential energy, however, is the energy stored in an object, usually based on its position. And gravity is a closely related concept because it depends on the position as well. So gravity is the force of pulling between any two objects, like how the Earth is pulling us down, as well as any other objects that are on Earth. We're all being pulled down. So whenever we jump, we get pulled back down into the ground. So we will look at how this gravity can make us store gravitational potential energy, and we will also look at how it can be converted back to kinetic energy. This is like a classic example with a roller coaster, which we will also see in the video. And you'll see that potential energy is the highest over here, and it gets converted to kinetic energy, and then it stores up again, and then we will have another loop. Let's look at a better example with a second video. So this will be another 15 minutes, but this will explore more about the potential and kinetic energy. So that was the video about potential and kinetic energy. Let's quickly review both videos. We first started with what energy is. So the energy is the ability to do work. And there are many different kinds of energy, such as light, sound, and heat. And we use energy all the time. It powers our lights. It powers the computer that you are using and that I am using as well. And it also helps us move our body. So energy is really everywhere around the world. And it doesn't have to be just powering things. Energy actually powers us to move. So before we continue, these are different types of energy, just to get you familiar with. So you can see there are a lot of different kinds of energy, like thermal energy, like the heat, the radiant energy from the sun. We also have light energy that gives off light. We also have chemical energy from chemical bonds. We also have nuclear energy. We also have electrical energy. We used electricity to power many things. And there are also gravitational energy and mechanical energy, which means the energy that is usually in motion. So anything that moves or helps it move has to do with mechanical energy. And you can see there are many different types of energy. So we also looked at how energy can be transferred. So energy transfer takes place when energy moves from one place to another. So energy really can move from one place to another. Like, for example, when you touch a metal spoon in a hot pot, you have boiling pot, water. It's very hot. But if you have a metal spoon in the hot pot, then the heat will be transferred from the hot water to the spoon. So it conducts heat. If a person touches the spoon, then it'll feel very, very hot. And that is because the heat from the water was transferred to the metal spoon. And there are many different sort of transfers happening all around the world. So you can see electricity powering any sort of device, for example, like a toaster machine that helps it produce heat. And do you guys know where we get our energy from? We Yes, you know where we get it? Because we need energy to move, right? But where do we get that energy from?
We get energy from the sun. From food.
Oh, yes, that's right. Oh, we get it from our food. So food has stored potential energy. It has a sort of chemical energy. So we will actually look at it in a bit, but we have stored chemical energy. You can see in the second picture over here, and over here as well on the right, that the stored chemical energy in our food, when we eat it, it gets converted to the energy that we can use. Mainly the mechanical energy, which we use to move, walk, and run, and do any sort of motion. We first need energy from the food. And there are also solar radiation energy that is converted to electrical energy we saw using the solar panel. And there are many other like electrical energy producing light. If you have a light bulb that is powered by electricity and it's get converted to light. And there are other things like chemical energy from the batteries powering a flashlight, or the oil that stores chemical energy, converting it to mechanical energy by the car, and many other transfers are happening in the world.
Okay.
Or we continue. I have one thing.
Awesome.
Energies are happening all around us. So I am looking through a couple of pictures and trying to see if there is a good example. For example,
Good.
let's look at this picture in more detail. So, all of our energy basically comes from the sun. So sun is the main provider of this radiation energy. So the sun provides all the energy that we need. And where does it get transferred to? It gets transferred mostly to the plants, because plants can perform photosynthesis, which they can provide their own energy. So the sun helps the plants grow. And the plants are then eaten by the animals. So the energy from the sun, gets transferred to cows, to chickens, and to pigs, to horses, to goats, and every other animals as they eat grass. So now animals have the energy in their body from the sun initially. So from the sun to the plants to animals. And now when we eat meat, or when we also eat vegetables, the vegetables storing energy, and the meat that we eat, for example, like the cow or the chicken, also has energy. So when we eat them, we get the energy that was originally from the sun. And all of it is basically a whole cycle of energy as it gets transferred from place to place. We saw how energy was transferred, but in the second video, if you guys remember, we talked about kinetic and potential energy. So these two energies are the main types of mechanical energy that we focus today. So remember, mechanical energy is the energy that moves, basically. Any energy that has to do with moving are kinetic energy and potential energy. So kinetic energy is the energy in motion. So if something is moving, it has kinetic energy. Potential energy, however, is a stored energy due to position or condition. So we say it has the potential to move. Potential meaning kind of having the ability to do things, but it's not yet ready. It's, for example, you can see the bottom picture. When you lift your leg up to kick the football, you're storing potential energy because your foot is off the ground. You're lifting it higher and you're building stored energy or potential energy. When you kick the ball, you release that potential energy into kinetic energy as you swing your foot and hit the ball, and the energy gets transferred to the ball. This is a classic example of how potential energy and kinetic energy works. We also talked about how potential and kinetic energy can be converted. So potential energy becomes kinetic energy when something starts moving, and kinetic energy becomes potential energy when something slows down or goes higher. There is a classic example with a roller coaster. So you see this ride, as it goes up, it's storing potential energy because it is getting higher. It has higher position than initially over here. So over here, it has a lot of potential energy, but as it goes down, as this roller coaster starts moving, it gets converted to kinetic energy. and it's speeding down the hill. And then because of the amount of kinetic energy, it has enough energy to go around the loop. And then again, as it goes on top of this hill over here, it also starts to build potential energy and then convert it to kinetic energy. You can see a lot of these conversions happening all around us. And this roller coaster was one example. And I have this sort of interactive simulation where you can see how the potential energy and kinetic energy are converted. So let's look at more details on this simulation.
Wow.
So
Wow.
we have this roller coaster, and I will play this animation, and you can see how much potential energy it has and how much kinetic energy it has. So let's play this quick. So you can see how there are just like play. You can see it's building up potential energy and it gets converted to kinetic energy back into potential. So we look at it step by step. Here's the first step. So this has 100% potential energy because it's high on top. And then let's go to the next step. This goes down over here. So all the stored potential energy gets converted to kinetic energy as it goes down the hill. You can see the next step. This is the third step over here. You can see the kinetic energy is starting to decrease and more potential energy is being built up as it goes higher. And you can see the rest of the clip showing how there was a buildup of potential energy at top and it gets converted back into kinetic energy. Yeah, this was a very fun, interactive way to figure out how kinetic energy and potential energy can be converted. And one final note to make is that there are different types of potential energy. So although there is only one type of kinetic energy, there are multiple types of potential energy. So for example, we have most of the examples that we looked at are gravitational potential energy. Remember gravity pulling us down, and energy is stored due to an object's height. So the more further we are off the ground, the more gravitational potential energy we have, because gravity is keep pulling us down, and when we're higher up, then we have more energy. The Earth wants to pull us down further. And we also have elastical potential energy, which is the energy stored in stretched objects. If you have a rubber band, or if you have a bow over here, as she pulls back, draws back the bow, you can see the potential energy that is stored in the bow. So a lot of energy is being gathered over here. And this is elastic potential energy. There's another potential energy called the chemical potential. And this is the energy stored in chemical bonds. So we looked at batteries, for example, as the batteries have stored can store potential energy inside them. We also talked about foods, how foods have potential energy, and when
Hello, Jamie. Hello.
Yes, hello. Hello. Can you hear me? Okay. Can you hear me? Can you hear me? Okay, so I hope this is better, but we also have stored chemical potential energy in our foods as well as in batteries. So those are all the examples of potential energies that were stored in objects. And now let's look at some related careers of all the different kinds of energy and energy transfer. So I heard some of you were interested in engineering, and for example, they might ask the question of how can we improve safety features in an automobile, in a car that protect passenger. So, saying false, does batteries not store energy as chemical energy? Yes, that's right. The answer is true. That is correct. Because batteries store chemical energy that we can use to convert it to many other, for example, electrical devices that can be powered by batteries. So batteries, they need to store energy as chemical energy. That is true. And then let's look at this question. So what is an example of energy transfer by heat?
Nobody was on.
So can anyone give an example of how energy can be transferred by heat?
So what is the answer there? Something there.
Yes, I heard a lot of examples of like prosthetic arms, prosthetic legs, safety features of an automobile, but mostly those examples have to do with mechanical energy, but specifically energy transferred by heat. It can be, as simple as cooking food on top of a stove or on top of fire. So when you have a pot, or if you have a piece of meat above fire, the heat that is generated from the fire gets transferred to the food and it gets cooked. So that is one example of how energy is transferred by heat. Let's look at a little bit more with this example. So
Started.
let's look. So let's answer one more question from kinetic and potential energy. So let's answer this question, this one last question. So when an object moves, where does the energy come from?
Hey, if you go past it, just the place will be talking free. I don't want to hear any noise.
So we looked at potential and kinetic energies.
Energy transfer.
Yes, energy is being transferred, but does anyone know where does it gets transferred from? Oh, yes, that's right. I heard potential energy, and that is correct. When an object moves, it has kinetic energy, but the energy comes from the potential energy. That is correct. And it can be from, we looked at gravitational, chemical, and elastic. Those were a couple of examples of potential energies. And yes, that's right. Energy comes from, when an object moves, it comes from potential energy. So, yeah, that will be the end of the questions. And okay. Do any of you have questions to ask about this lesson?
You have questions, ask. Be quiet. If you don't have questions, somebody has a question. So be quiet and let anyone have the question.
What is the meaning of gravitational potential?
Gravitational potential. If you talk about gravitational potential, better. Eric. Okay, ask me. Speak louder so that you can hear. Speak louder. Is that how best you can speak?
Please, what is the meaning of radiance?
Yeah. What's the meaning of what?
Radiance.
Radiant. Kevin, they say what is the meaning of radiant?
Oh, I heard, yeah, what is the meaning of radiant? So radiant means shining bright. So radiant, we talked about radiant in terms of radiant energy. So that is the energy that comes from the sun. Because the sun is bright, it gives off a type of energy called radiant energy.
Maybe see the picture for the iPhone.
Yes.
Huh?
Yeah.
Nuclear. Nuclear. David, what about nuclear? Nuclear energy. You were asking about nuclear energy.
We didn't really talk about nuclear energy because it is a little complicated. It has to deal with decaying of a certain nuclear compound, but we will not really get into more details, but know that it is a form of stored energy that we use to convert it into energies that we use. So maybe some of you have seen these nuclear plants. It's kind of shaped like this. So if you've seen pictures like this, these are where nuclear energies are stored and converted. So inside these large plants, we call them plants because they are places where they store nuclear energy. Inside these, they have stored compounds that break down and produce energy. But we will not get into too much detail about this. Just know that it is a type of energy that is stored in a certain object.
Okay.
So if you're curious about radiant energy, you can see that radiant energy is the energy of electromagnetic. So we didn't really talk about this again, but radiant energy is basically in a form of light, in some of which we can see and some of which we cannot see. So we have this thing called electromagnetic spectrum. So all of these are radiant energy. So quickly covering this. This is specifically radiant energy. And the light that we can see from the sun is within this small part of the spectrum of radiant energy, and this is called the visible spectrum because we can see it. We can see colors of the rainbow, like red, orange, yellow, green, blue, navy and violet, and these are the visible parts, but there are also radiant energy of different frequencies. These are different frequencies, some of which we cannot see, and some of it which we can barely see. There are also like infrared lights, microwaves, radio waves, and ultraviolet, X-rays, and gamma rays. These are all different types of radiant energy. It's called radiant energy because it gives off in a spectrum. So yeah, this was a quick overview of what radiant energy is. So yeah, if there are no more questions, we will talk about ecosystems next week. And
Are you listening? Is that what? Okay.
yes, that's right.
So next week is ecosystem. Yeah, so you can revise on that before you come, so that you can have more questions for JB. Is that okay? All right.
Okay, yeah.
I think.
Thank you all for listening, and I'll see all of you next week.
Hello.
Yes, can you hear me? Can you hear me?
Hello.
Hello?